Hello viewers, this is part 2 video for the course Digital Electronic Circuits week 6 assignment 6. So we will move on to the 8th problem. 7th problem completed, up to 7 we have done, 8th one. So we need to solve for this 8th problem. We will see the solution. So let us try to understand what is the problem here. So we have to multiply these two number. The result is also given. So this is a binary number, whereas this is octal number, and this is also the result output. The result is also binary. So we need to find A, B, and C values. A, B, C values. We try to find out. So this is a multiplicand and this is a multiplier. So if multiplier is 1, simply reproduce that number. And if for next multiplier 1, shift that left one bit position, shift the multiplicand 1 bit left position. For 0, it is all zeros, multiplicand will be zeros. So if we add this number, because this is B, the first digit is B, and in the answer they have given this as 1, therefore B must be equal to 1. B must be is equal to 1. So according to the solution result, this is 1, here it is B, so this B must be equal to 1. So assuming B equal to 1, if we keep on adding, to get the remaining result, A has to be equal to 1. A must also be equal to 1. So if we go on proceeding by adding A equal to 1 and B equal to 1, and finally if you see the options, for A equal to 1 and B equal to 1, C is equal to 0. C is equal to 0. So the only option, A is equal to 1, B is also equal to 1. So the only option given is C is equal to 0. So the answer is option C. Ninth one, how many numbers of 4-bit comparators are required to implement 32-bit comparators? So simply divide 32 by 4, we can get I think 8. 8, option C. And 10th one, which of the following statements are false? So the following statements are false is, we will see the answer for that one. What is the answer I have given? See number 3, allowed values, 3 is okay, but 4 ones is not allowed. Here 4 1 is not allowed, therefore 3 is wrong, 3 is false. One more we will see here, XNOR gate, actually used is XOR gate. So 3 and 4, option B, 3 and 5, 3 and 5, B, option B, 3 and 5, this one, not XNOR, it is XOR. Okay. Next one, 11th one, perform the following addition and subtraction operation using XS3 code. So addition and subtraction, so it's again a simple thing. I have done addition, subtraction. So this value, you can see here, this is 9 and this is 3. So what is the answer? You can see here, this is 9 and this is, one second, I have not completely done the thing. Now what we can find is, the answer is 1 triple 0 1 1 double 0 0 0 1 1. So for this one, 1 triple 0 double 1 0 0, and this is 3 and this is 9 and this is 4, and that is 4. So this is 4. Okay. So option D, it is option D, this one. Similarly, you can find it for subtraction. 12th one. So here D is given, small d is also given. So we need to find x, y, z, and z value. How to find x, y, z value? So what I did is, This is simply a 1 x y z 101, and they have given this is multiplication operation. Multiplication. 1 second. Okay. So that is the multiplication operation. So multiplication on this. So what we'll get? So star is given. So multiplication. Star means multiplication. So I had a slight doubt. Okay, slight doubt. So what we'll do here is, this is again a multiplier and this is the multiplicand. If multiplier is 0, multiplicands are all 0. If multiplier is 1, reproduce the multiplicand as it is with the 1 left shift. So again it is 0, all multiplicands are 0, and then multiplicands are 0. If it is 1, shift again by 1 left, shift the multiplicand by left position 1 bit. So if you add all this, so what we will get here is, but you will get this value. If you add all these numbers, you will get this value, binary value. But finally we have to add 1. We have to add 1 according to the given problem. According to given problem, we have to add 1 to this one. So that will be, so if you add this one, so that can be obtained only if z is equal to 0. So comparing with t, comparing with 0, z equal to 0, y is equal to 0, and x equal to 1. X equal to 1. So 12th is x equal to 1, y equal to 0, z equal to 0. X equal to 1, and yz is option C. Option C. Yz 0 0. Yz 0 0. Yz 0 0. X equal to 1. So then 13th one. So 13th is a very tedious problem. So I have solved here 13th one. So what I am trying, this is given x3, x2, x1, x0 given, y3, y2, y1, y0 is given, and for half adder we need to find only the carry, it is 0. For full adder we need to find the carry, that is also 0, and we need to find also the sum of the first half adder, full adder 1, this is also 0, and similarly we have to find it for full adder 2, carry as well as sum. For the third full adder we need to find carry and sum. This is for the first row. Similarly for the second row. Similarly for the third row. We need to find for third row. Half adder, then full adder 1, full adder 2, full adder 3. So finally what I am getting is 0 1 0 0 0 0 0 1. That is the answer. So 13th one is 0 1 0 0 0 0 0 1. Option D. 14th one. So we will see what is the 14th. It is regarding IC 74181. IC 74181. It is option D. So what is option D? 2 and 4. So 2 and 4. So this is correct. True regarding the 7481. You can see in the lecture. This is wrong. Because if m is equal to 1, L, it is actually arithmetic operation. And this is greater than 4. This is also is wrong. So therefore 1 and 3 are wrong. 2 and 4 is correct. 2 and 4. Option D. 15th one. So we know that reflected binary code is the gray code, which is used for error correction. Option D. Thank you, viewers.